Welcome. In this lesson, we will be learning about atomic mass and isotopes. Atomic mass refers to the number of protons and neutrons that are found in the nucleus. These are the only particles found in the nucleus, and remember, the mass of protons and neutrons are equal to 1 atomic mass unit. Our electrons have a negligible mass. They're so small that we don't bother to include it in our atomic mass calculations. So our atomic mass will tell us how many protons and neutrons we have around and how massive our atom is. And here we're only going to count our protons and our neutrons because they're the only ones that really have mass. So we calculate that atomic mass by adding up the number of protons and the number of neutrons that our atoms have. So this example, our element contains 13 protons and 14 neutrons. So what's the atomic mass? Right, so mass equals protons plus neutrons. So we get 13 protons plus 14 neutrons. Will give us an overall mass of 27. Beryllium, for another example, has an atomic mass of 9, so that's the total mass, and an atomic number of 4. And this question wants to know how many neutrons does the nucleus contain? So this isn't quite as straightforward as the first example. We have to do a little bit of thinking about what's going on here. So our total mass is 9. So that's our protons plus our neutrons is 9. The atomic number is 4. And remember, the atomic number is the number of protons. Right? So if we use our equation, mass equals protons plus neutrons, we have atomic mass, that's going to be 9. We have number of protons from our atomic number, so that means that we can determine the number of neutrons. Right? So I can just do some quick math here. I get 5 equals neutrons. So I have 5 neutrons, 4 protons for a total mass of 9. So an isotope is a special kind of atom, and these are atoms of the same element that have varying number of neutrons. Right, so remember, the same element means we have the same number of protons, right, or the same atomic number, but we'll have different atomic masses, right, due to the different number of neutrons. And we can indicate isotopes by their mass number, which is either written after the name, right, so carbon 12 indicates a carbon atom with a mass of 12, and so does this, where we have carbon with a superscript up on the left-hand side. Right, so any atoms that have the same number of protons but different number of neutrons are going to be considered isotopes. So if we look at this example, which 2 of the following 3 atoms are isotopes of each other? Right. Isotopes, same type of element, different mass. So here we've got carbon and carbon, that's the same element, and they have different masses. Right. Nitrogen is not considered an isotope of either of these because it's a completely different element. So our 2 isotopes are going to be carbon 12 and carbon 14. Right. Same number of protons, different number of neutrons. So we can have 3 different types of oxygen, 3 different isotopes, indicated as O16, O17, and O18. Right? This means we have a total mass of 16, 17, or 18. In terms of subatomic particles, what do these isotopes have in common? Right, and the answer here is going to be protons. They're all oxygen, right, which means they'll all have the same number of protons. In terms of subatomic particles, what is the difference between the isotopes? And here that's going to be neutrons. Right, we can add some neutrons into our nucleus. As long as the protons are the same, we still have oxygen. And we can do a couple of practice Regents questions here with this type of idea. So a neutral atom with 6 electrons and 8 neutrons is an isotope of, so here we have to think about a lot of things in this question. So a neutral atom means that we have the same number of electrons as we do protons. So when it tells us we have 6 electrons, they're really telling us that we have 6 protons as well, because it's a neutral atom. And it's giving us the number of neutrons as well. But remember, protons are what identifies an atom. So if we have 6 protons, that means our atomic number is 6, which means we can go to our periodic table and find atomic number 6, and that is going to correlate with carbon. Carbon has 6 protons. In our next example, we can look at which symbols represent atoms that are isotopes. Right? So isotopes have to have the same element with different masses. Right? So if we look at A, we have different elements, carbon and nitrogen, with the same mass. So that's not going to be the right answer. With B, we have radon and radium. Those are different elements with the same mass, not isotopes. For D, we have iodine for both of them, which is promising. So we have the same element, but we also have the same mass. And isotopes have to have a different mass from each other. So D is wrong because of that, which leaves us with C. And here we have oxygen and oxygen, so they're the same element. We have 16 and 18 in different masses. So this is a definition of an isotope. Same element, different atomic mass. And then for our last example, what is the mass number of an atom that contains 28 protons, 28 electrons, and 34 neutrons? So here we need to remember mass equals protons plus neutrons. Right, so we have 28 protons and we have 34 neutrons. That's going to give us a total of 62. Right, or answer C. Okay, so that's it for this lesson. We talked about isotopes, and those are the same element, same number of protons with a different atomic mass due to differing numbers of neutrons. We should be able to write them out, right, in symbol form with the mass after or in a superscript, and identify isotopes of each other. Good job today. See you next time.